My name is Mickael Alliel. I'm currently a DevOps tech lead at Commodore, where we build the next-gen Kubernetes operations platform. And today we're going to talk a little bit about load balancing and how it works in the multi-cloud, and basically why it's so complex than ever working with infrastructure like this. So first of all, let's take a look at why multi-cloud is complex in the first place. One of the obvious flaws of the multi-cloud is that every cloud provider is a bit of a multiple of the same. They all offer the same feature set. They all work kind of the same, but the underline is that they offer the same feature under different names. They work a bit differently, the way you configure them or the way they behave. And this is just the things that most people know about. There's a lot of things that people forget when working with multiple cloud environments or cloud providers, such as configuring things in a different way. That is a requirement when working with multiple cloud providers. How would you go about aggregating visibility metrics and data on multiple clouds, tracking or kind of decentralizing the state of your infrastructure across multiple providers in your environments, and of course, routing traffic from your users to the applications that you're providing. And load balancing is a topic that we can talk about on its own and why it's so complex on how to set up proper load balancing and making it work. But when you combine it with multiple environments working on different cloud providers, the complexity just becomes so much more. And we can take here first one use case about how would you use a load balancer in the multi-cloud. So there's a few different options. Here we're going to talk about having one load balancer acting as a global entry point to your system. And the point of this layer 4 load balancer is going to be to divide and balance traffic through different multiple cloud providers. If you're working with GCP, Amazon, or Azure, you might have like different requirements based on your customers or application to route traffic to a specific one. When you get the traffic to that cloud environment, then you have a different load balancers that is routing traffic to your application. The complexity of this architecture, although it seems a bit simple on this graph, is that you have to know which load balancers you're using at every step of the way. They might be the same, they might be different depending on what you're using. But the thing is, configuring 4 different things, synchronizing them and making them all work the same way across different and multiple environments is something that is very hard to do. So what can you expect really from this talk? First of all, trying to understand what is the use case of using multi-cloud or your use case in that occasion. Getting to know what your options are in terms of what would you need to make this work and what load balancers could you choose and why would you choose them. And of course, there's always the complexity of making the right decision at the end of the day. It's very easy to say, okay, I'm going to try out X. I'm going to go with it and see if it works for me. But making the right decision from the start is always harder than you think. And for that, we're going to start with asking some hard questions. Basically, what is the requirement of your business or your applications in terms of load balancing or in terms of your environments? Do you even need multi-cloud? Are you working with just one single cloud provider? How would your traffic need to be routed? Does it need to go through one specific cloud or environment? Is it okay to just balance it out across anything that's available and less overloaded? How would you go about configuring all the load balancers, keeping kind of track and synchronizing everything together and gaining visibility on all of these platforms and infrastructure and pieces of software? Basically, every cloud provider, for example, gets you logs and metrics about everything that you use over there, but getting it to the one centralized place that your company is using is sometimes hard, and it's very hard to make it all look the same and easy for your developers to use and see. And of course, for anything that you're getting to work on any cloud or environment, you want to test it. You want to do changes and make sure that you're not going to break production at the end of the day. So you need to figure out what is the right way given your use case and what your choices of load balancers and environment are. How are you going to test it locally? Is it even possible to kind of simulate how it's going to behave on the environments, on the cloud providers, as it would do on your computer. So now that we got that out of the way, let's see a bit what our options are in terms of load balancers. So we're talking a lot about cloud environments and providers. So the main big ones are Amazon, Google, and Microsoft. They all offer managed load balancers, which is very nice because they get out a lot of the work that you would need to get a load balancer up and running. They're very, very scalable because everything is abstracted behind the clouds. But the thing is that they're kind of low visibility by default. It's hard to get metrics. For example, if you use Amazon ELB, then you have to set up the logs through a bucket and configure everything. It's not just reading logs. And they're also not very configurable. It gets better each year that they improve their load balancers, but there's a lot of things missing that you just can't do when using a managed service like that. Then, of course, we have the open source load balancers. I think the most widely used and known one is nginx. It's very, very performant, very scalable if you know how to use it. It does great for applications, static content, reverse proxying, and all of that. But I think there's an issue with the mindset behind nginx that everybody thinks it's so easy. And everybody wants to use nginx for the POC or just getting something to work quickly, right? But the moment that you do that, and then you forget about configuring it properly or making your use case proper to using nginx, then you run into problem in terms of when you scale later on, then you just forget that you didn't configure anything and something breaks and don't understand why. There is HAProxy, which is a really great, like 20 years old load balancers. It's very battle tested. It has a very large and extensive documentation. A lot of available features. It supports both layer 4, layer 7 compared to some other load balancers. So this might be a good choice for multi-cloud environments, for example, if you want to use the same piece of software for all your use cases. The thing with HAProxy is because the set of features available is so large and the documentation is so great that it can become very hard to configure because you have so many options. And sorry, HAProxy, but your documentation looks a bit like it's from the 50s. And the last load balancers we're talking about is Traefik. It's a bit more modern. It's, I think, 5 years old or something like that. It has a REST API for configuring and debugging it. It supports newer protocols like HTTP2, gRPC, and things like that very well compared to others. The thing with Traefik is that it's, because of it being new, it has a lot of unknowns around it. Less people are using it. It has a lesser community, for example, than nginx, and it's harder to find solutions to the issues that you might encounter. So we've talked a bit about how would you go thinking about why you should use multi-cloud or not, and if your application can even behave that way, and some of the options about load balancers. So now remains the question, where do you go from here? What do you choose? What do you do? And is it the right choice? I think about it a bit like choosing your own house. If you want to rent, to buy, or anything like that. You want the house with the biggest rooms, with a garden, with a pool, with a garage, everything. You want it the best, right? So it's the same with choosing a load balancer, for example. You want just all the features. You want everything to work. You want it to be very scalable and all of that. But the thing you forget is there's always going to be changes in requirement. There's always going to be maintenance going on in a few months, in a few years. And my advice is to just think about the shorter term, what you currently need right now, what is your use case for the next month, 2 months, 3 months, 6 months, get it up and running, see that it works, and just be prepared to make some change if necessary. But the moment that you go to taking everything that you might need, then nothing is going to work probably, not on the first time at least. And for that, I've prepared a quick cheat sheet that it might help you, I hope, choose the right load balancer for your use case. Of course, there's a lot more to think about and ask yourself when you want to use a load balancer for which purpose, but this might help it make easier for you. Thank you, everyone.